Yeah, I thought about having some type of automated thing like a clown or something, but okay, you get me instead. um, my talk is about applying NASA Standard 7009, and it's a standard related to models and simulations, uh, and I'll share some experiences and exposures. And to prep myself for this presentation, I have a joke, and I know this is on YouTube, so sorry. But Chuck Norris can fly a real plane using Flight Simulator. You'd be surprised at how many of the IT jokes are related to Chuck Norris. So that was just a find while I was prepping for this talk. Okay, it's a very long list here, but a lot of this is just giving you backstory about the history of 7009 and its objectives and why and who uses it, and how it fits into the larger picture of the software development lifecycle, and a couple of projects were willing to apply it to their missions. So, and then I'll take questions. So that's really the direction. Next one. And this is automated, so you can next. Okay. This standard, the Models and Simulation Standard, was created as a direct result of the Columbia accident in early 2003, February 1st. The Columbia accident occurred, and an investigation board was created as a result to kind of identify areas of weaknesses that could be improved, and to identify causal relationship between software and hardware and the actual incident. So one of the things they identified was that there needed to be a better consistency in standards for the development and documentation of models and simulations, because at the time of accidents, you want to have a quick turnaround and very well documented models so that you can send up accurate information in a pinch, you know, as it, yeah, in the case that it ever happened again, God forbid. So as a result of that action being generated, the next report which was generated, it's called the Diaz report. Al Diaz, who used to be director of Goddard, was asked to take a look at the details, the technical information related to models and simulations, and how it can be vetted more technically. And he basically vetted that particular finding into that all programs should produce, maintain, and validate models to assess the state of their system and components. This relates directly to the concept that models and simulations are often used by high-level decision makers to make critical design and architecture decisions. And so it furthered the detail, and as a result of that, NASA Standard 7009 was born. And it just elaborates that we want to make sure that information that's being provided to decision makers are also being have accurate information, and they're well documented, and that the input and output involved with that each of these models are well understood by those making decisions and the technicians that modify them. Okay, next. This is a direct snap from the objectives of 7009, and it basically goes down the process, down it's a laundry list of things that should be done to models and simulations. It identifies best practices. It looks for, it boils down processes that can be applied to the less than structured models and simulations that we use for software development. And there are recommendations about documentation standards and configuration management, so that as these tools are being developed, that we know what we know what is contained within, you know, the uses of the models and simulations. And then finally, that the users that will, that these models and sims have a good plan for updates, and that users who encounter problems with interim versions have a way to feedback this information so that it can be updated and improved. Okay. I did anyone could, did a search on who's used this NASA standard. It was established in 2008. So it took, in 2003 was Columbia, 2004 was the Diaz report, and it took a few years to evolve and develop into an official standard in 2008. Right now, the MPCV, the Multi-Purpose Crew Vehicle, is applying the standard for their development in their GN&C especially. DOD and the FDA and NIH are using it to help contain their development in the biomedical environments. And there have been, this is just a short list of information that was available by anybody, but each of these environments, the National Academy of Sciences, each of these groups have applied this and adapted this standard as a point of reference. So it's become something of note in a lot of fields. So, and it keeps on being applied as I'm talking about it, even in the IV&V environment. Okay. You know, and I kind of touched on some of these information, but why is it so important for models and simulations to be well documented, well structured, and their usage well known by the users? And one of the things that models and simulations, mainly simulations in this case, is that it allows well, models too, because they interact at the early stages of development. It allows a project to exercise software so that different parts of the system can develop quicker, and it allows for quicker development to progress before hardware may be ready to be run. The example is that you can exercise commands to thrusters without firing the thrusters, because that would be unsafe. The other thing is that simulations especially allows for is the ability to run many scenarios, more than real life would enable. So by the time that software and models come to their point of development, the point of delivery, they end up enabling the developers to have a fairly well-developed understanding of whatever subsystem that they're modeling. And the other thing that's very important that this standard lends itself well to is that part of the output of this is to provide this model documentation to decision makers. And oftentimes these decision makers will choose not to use a bus or choose to use a certain solid state recorder, or based on these simulation data that they'll receive from early stage testing. Okay. So what gets encountered in this particular topic is that you're balancing between structure and dynamic environments. And the idea is you don't want to squelch the creative process, the development process, with too much heavy requirements for documentation, but you want to allow developers to develop and provide important feedback to people who will make the decisions. And the cons to this particular balancing act is that configuration can be difficult. I've experienced it. I think anyone who's used a model or simulation has experienced that one particular version of a model or simulation may involve many different aspects in its environment. It'll involve you know, a certain operating system. It'll involve various versions of components within that product. And so keeping track of that has been, and that was why the standard was created. Keeping track of that was difficult, and it showed itself to be a challenge. So it still is a challenge, but the standard helps to address that particular challenge. And the other thing that happens is that the people who are prone to models and simulation development tend not to like to do documentation. Because they want to do real work. They want to really do software, and this brings them down. It harshes them. But anyway, it's important because the people who are keeping in mind who will be using this data will allow for better and more efficient development of the final products, the models and simulations that survive the vetting process. But keeping that documentation up front is key because you're talking to management. You're not talking to the technical people. So that's a challenge there. Okay, along these veins, I've personally participated with 2 evaluations. One was much more elaborate, and you've heard about this project in various settings along these 3 days. The AMF Project, the Analysis and Management Framework Model. They did a criticality assessment this summer utilizing the NEAP program to help do the documentation. But they went through the full 9 yards on this one. They applied as many of the requirements within 7009 as they could. As time went along, I thought there needed to be a second sample for, you know, just for seeing how projects respond. And JWST participated, and it was a much more abbreviated version. It was basically the Reader's Digest version of 7009. I don't know what to call it, but it was with the same intent, is to, if they could pull up the documentation related to their models and the databases that control their development or are involved in their development, the better it is for everyone involved. So those are the 2, and I'll go into each one individually. I'm lucky enough to have the AMF team here, willing to share if needed. But the AMF project basically is a, can I say data warehouse? No, I can't. Okay, strike that from the record. It's basically a model that has been developed to help manage data products for NASA IV&V. It's in development, so it's not yet done yet, but it has been working toward that goal. The method that they did was they imported the actual standard itself into the model. The particular tool that I'm talking about has been very well suited to being able to import documentation and tracing to individual elements within each document. So it was basically decided, they decided to use this as a way to trace within their model how they met each standard. And because it can trace to, or it stores the data per each element level, they were able to do this trace fairly straightforward. It's a straightforward process. So I made just a representation of what they did. They took each AMF model element and they assessed it based on each 7009 requirement that applied to that model element. And so what came out of that was a set of traces that where each trace was basically the assessment of that element using the 7009 standard as a frame of reference. So I think it was a very good organized effort. And like I said, a summer NEAF student did it, but he did a very good job, Robert Hewitt. And he was able to make sense of using the model and understanding the standard well enough to be able to work through the tracings and the assessments. And he had the team reviewing his work so that it's a representation of the team's effort. And the results of this were stored, so the assessment, the criticality assessment, was stored within the model. And so to be able to be extracted in any form needed, but available within the model in case you're in the middle of a development of an element or using referencing an element, you can see how it stacked up against the 7009 standard. Ultimately, there'll be an assessment report that'll be generated from the AMF model. So stay tuned on final results, but the idea was they did the assessment. Let me make sure I have, and the results are on the next slide. The results were that based on the phase of development that the AMF model was in, that the 7009, that the AMF project was 7009 compliant. There were more activities to be done in the future that they'll do as their development allows, and that is to generate an assessment report that will have content relevant to the model, but is also communicating to those that would make a decision about that model, management and other people who may not be able to look within the model itself. And also that's in progress right now. They're working on training about how AMF can be used. I know there were sessions earlier in this workshop. So those two things are a result of the analysis. But the training was going to happen anyway, but how 7009 is going to be a sub-element of that training, how 7009 was applied. The second project that I did, this one was quick, was the JWST criticality assessment. Basically, I sent them a set of 20 questions, and I really did only have 20 questions. And I asked for feedback for each one, whether yes, no, and if yet, either way, to provide details about why it was yes and why it was no. It was a set of questions, and these are 5 questions that kind of are relevant. Do you document the model, the database usage? The JWST program, let me go step back one step on this. They have a fault management database that they have been using as a way to build their progressively over their analysis on what they have related to fault management, and they've been using it as a part of their own IV&V assessment. And so that particular approach has been integral into their evaluating fault detection and fault management in their within JWST from an IV&V perspective. So they've been using it as a model, basically, and it's integral into their analysis, so I thought it apply. The other aspect is, did they document the components that are contained within their database, and how do they apply configuration management? How do they manage the changes of their model? Do they baseline it? Do they have patches? How do they manage that? And is their input into the data into their database, is it well established? Is it set and defined? And is the output also set and defined? That's one aspect that 7009. When you think of configuration management of a product, sometimes what gets overlooked is an input database, an input data set versus an output data set to be combined with that particular modeling element. So as versions continue, they're able to say, given this input, this is my expected output, and they can judge based on output changes if their model has done what they expected. It's how they judge basically how things are successful. So it also, in addition to the modeling and the components usage and versioning, they also need to record the input and output data sets. And basically they answered all the questions with more detail than I expected, which is not surprising based on the participants. And my ultimate goal was to familiarize them with the 7009 standard. And I was able to achieve that. They were wondering originally why I was asking some of these questions. And once they understood, there wasn't too much of a turnaround, feedback iteration, but it was fairly good. And based on those two exposures, the full-blown and then the abbreviated version, I came up with some reflections which are common sense as well, you would imagine. The earlier in the life cycle development that you can apply these principles, the 7009 principles, the more likely you'll have, it'll improve the quality of your model and simulation. It's, I guess, common sense, good practice. It's also the information needed to answer the questions in 7009 are also, they match well with system engineering best practices. And I had recently found out that there was an effort on the NASA side that, from headquarters, I believe, to see how the 7009 complied and matched up with the current system engineering handbook elements. And I have references if people are interested. I have an updated backup slide, but I just wanted to let you know that it matched up fairly well, and there were aspects that didn't match up, and the constraint that they put on these models and simulations that didn't apply are the ones that are embedded within the software. They're not going to be evaluated in the same way that a typical product that is interfacing with your software. So there had to be a delineation about embedded versus external. And once that was made, it matched up fairly well. And at this point, I forgot my question slide, but I'm open to questions.
Once again, to ask a question, please press *1 and clearly record your name.
Are there any questions in the room? Are there any questions on the phone?
There are no questions.
No questions online either. All right, thank you very much, Darilyn.
Thank you.